Hello everyone, welcome back to my channel Data Mine Insight. Today we will discuss about circular queue, which is the extension of linear queue. So before watching this video, I will recommend you to watch my previous video on linear queue, where I have explained linear queue in detailed manner. So I have given the link in the description box. So let's get started. So in order to understand circular queue, we might need to take a recap on the linear queue. So in linear queue, we have two pointers. First is front and second is rear. And initially front and rear is equals to -1, which will tell us that our queue is empty. So if we insert an element into the queue, we will increase our front by 1 and rear by 1 as well. In the very first element, we can initialize our front with 0 and we will increase our rear by 1. So let's see here how it works. As you can see here, we have inserted two elements. So where is our front? Front is at 0 position. And where is our rear? Rear is at 1 position, means first index of our array. Now we have inserted multiple elements and this queue is full. As you can see here, where is our front? Pointing at 0, and where is our rear? Rear is pointing at the end of our queue. Now we cannot insert more element into it. Now if I want to remove any element from this queue, then we have to use dequeue operation. Basically, enqueue operation used to insert element inside the queue and dequeue operation used to remove element from the queue. And in this case, we will increase our front by 1. So for dequeue operation, we will increment our front by 1. As you can see here, we have removed two elements or dequeued two elements and we have just increased our front. So you must have to remember, whenever you will insert very first element, you have to initialize your front by 0 and you have to increase your rear by 1. Okay, we have already just mentioned here in this slide as well. So next value, if you are going to insert inside the queue, then you have to increase your rear by 1. Each time you will insert value, you have to increase your rear only, not the front. So when you will remove value, then it has to follow first in first out. So what was inserted first? It was 1, then 2, then 3. So we have removed or dequeued from the 0th position, then the first position. And one more point to remember is, when you are enqueuing any value inside the queue, then you have to check whether the queue is full or not. If our queue is full, then we cannot insert any element inside the queue. And when we are dequeuing or removing any element from the queue, then we have to consider whether the queue is empty or not. If our queue is empty, then we cannot remove any element from the empty queue. Let's move forward. So what is the problem with linear queue? As you have seen that we have dequeued two elements and now we got free space over here. And in linear queue, we can insert element after this. So we cannot utilize this space, correct? So in order to utilize this space, like 0 and 1, if we dequeued 2, then we need to utilize this space as well. So in order to optimize our memory or use memory efficiently, we need to use circular queue. So at that time, circular queue comes under picture. So there is an interview question. What is the difference between linear queue and circular queue? So you can say, in order to use linear queue, we cannot use memory very efficiently. So whenever we will dequeue elements from our queue, we cannot utilize that space again. And if we will implement the circular queue, we can utilize this empty space again, because circular queue works in a circular way. So how circular queue works? So circular queue works according to the circular movement. We have a circle where we have stored multiple values. We can store multiple values starting from 0 to 7. So first we will store it on 0, 1, 2, 3, 4, 5, 6 and then 7. Is left on 0 again. Let's suppose we have removed any value from 0, then we can utilize this space again. And if we have removed value from 1, then we can utilize the 1 again. This is called circular queue. So whenever you are removing data from any of the place using FIFO method, then you can utilize that space. Let's simplify this. So you have inserted two elements inside the queue. Insertion of element can be called as enqueue. We have inserted two elements. So front will be at the very first position and rear would be at the last position where we have inserted the next element. So after this we have inserted second element, third element and the fourth element, and by this we have to increase our rear by 1. So we have incremented our rear by 1 plus 1 plus 1, and we have incremented till 4. So we have completed our enqueue operation. Now we have started dequeuing our values. So according to FIFO, we are removing our values. First we have removed the very first position, which is 0. Then after we have removed the value from the first position, which is 1, index 1. So where is our front now? So once we will remove element, we need to increase our front. So we have increased our front by 0, then 1, then after our front is at 2. After this, if we remove this value, then our front will be at 3. So here you can see we have two space which is not occupied by any value, and we have 0 and 1 here, which is empty now. Now we can utilize this space if we are using circular queue movement. So after fourth index, we can insert more element into it. So if we have inserted 6, then where it will accommodate, this will get accommodated in onto the 0th position. After this 6, we can insert 7 at the first position. Alright. Now you might have below questions. How to check queue is full? So here you can see where is our front and where is our rear pointer. Our front pointer is pointing at 0th position, and where is our rear pointer? The rear pointer is pointing at 4th position of our queue. So here we need to check front is equals 0 and rear should be at size -1. Size is 5, -1 is 4. So this could be a case of queue fullness. So this is the one of the hack which I discussed with you. Now what is the second case? Let's suppose we have removed two elements, 1 and 2. After this, I enqueued one element over here, where on the 0th position, which is 6. So from here, our rear pointer just arrived on the 0th position of our queue. And where is our front? Front, because we have already dequeued two elements, our front is at 2nd position. Is this queue full or empty? We can say we are left with one space, so we can insert one more element over here. So our queue is not full yet. Now let's observe, if we have inserted one more element in this queue, where is our front and where is our rear? So whenever our rear is just behind the front, or we can say our front is just next to the rear, then our queue is full. So if we remove this value from here, then where would be our front? Front would be at 3. So we at that time our queue would be empty for one space. Then if we insert one more element in that queue, then where would be our rear? Rear would be at 2nd position. So our front is at 3rd and rear would be at 2nd position. So this would be a case of queue fullness. So what you need to observe here is, so whenever our front is just next to rear, that is a case of queue full. So we have added here front is equals to rear plus 1. And I have already showed you this code snippet here as well. So if our front is equals rear plus 1, or front equals and rear equal size -1. So here we are covering this case, and in this space we are covering the second case. And if we got this condition, then we will return yes, the queue is full, otherwise we will return 0, queue is not full. Now let's discuss one more point over here. Once at end of queue, how to begin. So before going forward on this question, let's take an example of this formula. So here, what is our rear position? In the very starting, rear would be pointing at -1. So -1 plus 1 is equals 0. Then we have added modulus sign. And what is our size? Size is 5. So what would be the result? Result would be 0, because -1 plus 1 is 0, modulo 5. So what would be the modulus? The modulus will be 0. Next, we have incremented our rear. What would be the position of rear? 0 plus 1, and modulo sign, 0 plus 1 is 1, modulo 5. So it would be 1. Then after we need to follow the same method again and again unless we reach at the end of the queue. Why I'm saying end of the queue? Because at the end of the queue we will just need to forward our rear pointer at the beginning of the queue. So let's suppose we have reached 0, 1, 2, 3 and 4 at the end of the queue. What would be the position of the rear? 4. So 4 plus 1 would be 5. 5 modulo size is 5. So 5 modulus 5 would be 0. So again our rear pointer will point to 0 position. Then after, what is our rear position? Rear position is 0. So rear, if I just wanted to insert, if I just want to insert one more element, previously it was on 0, now I just wanted to insert one more element. So what was the position? Rear was at 0. 0 plus 1, 1 modulo 5. So it would be 1, and again we have to follow the same condition. So as you can see here in this code snippet, I have already implemented this in the enqueue method. First we have checked is full, then front is equals -1, front is equals to 0. So at the very first time we will need to just initialize our front with 0, and then after I will check, or I will implement this formula over here, rear plus 1 modulo size, and then will insert the element in the item array. Now the same thing we need to do with the dequeue method. So at the first, where is our front? In the very beginning, our front would be at -1. So -1 plus 1 is equals to 0, then modulo sign and size. So its size is 5. So -1 plus 1 is 0, modulo 5. It would be 0. Then after, if we just dequeued one more element from our queue, then front would be at the 0th position, 1 position, 1 plus 1, 2, 2 modulo 5. So it would be 2, then 3, then 4, then 5, and after 5, let's suppose our front is at here, then we have to move our front at this point. At that time, we need to consider front position at front position 4 plus 1, 5, 5 modulo 5 is 0, then our front would be at 0. Okay, so I have implemented this in here as well. So in the next video I will discuss about the program, how we can implement all these formulas or all these cases in our code. Let's discuss in the next video. I hope you enjoy this video. Please like, subscribe and share. Thank you.